from some primitive animal whatsoever. For what we can say, observing the human chromosomes or the human DNA and comparing it with that of other species, is that man is original. Man is not derived from any other species. So the statement that man is a recent creature coming from some primitive form cannot be supported by genetic data at all.
One of the problems facing geologists today is the fossilized tree. There are a number of examples in Australia and America and elsewhere where a fossilized tree can be seen running vertically through a number of coal seams. Here's an example from the coalfields of Birmingham in Alabama in the United States. Some of these fossilized trees, 12 meters or more in height, can be seen running through a number of banks. This model gives some idea of the situation. Now, the curious thing is that we are told that any one of these banks takes millions of years to form. Now, if this was the case, it would take millions of years to bury the tree. But that's not possible, because the tree would decompose or rot long before it was all buried. So, what is the explanation? Well, a scientist has studied the problem, and the episode you're about to see will give you an idea of the implications of his startling but exciting discovery. Now, in order to understand the explanation, it's important to know the difference between a layer and a bank. These are banks, these areas colored orange and yellow and bluish. In each bank, you can see a number of strata. What you can't see are the layers. You can't see them because as each layer of sediment arrived, it sorted itself out into the banks that you can see. If you could see them, they would look something like this. After you've seen the film, you will understand why knowing the difference between a bank and a layer is so important. It not only provides the key to the fossil tree problem, but it also explains why the theory of evolution is crumbling. And what's so important about those rocks? Well, they're not any old rocks. They are made mostly of tiny grains of sediment. They are called sedimentary rocks and cover 3/4 of all the land on Earth. And what's more, they were formed under the sea. When the sea level dropped and the sediments were exposed to the air, they dried out to become rocks.
Look at this cliff face. You can see it is divided into banks. The bank of sandstone has been colored yellow, the bank of clay blue, and the limestone colored orange. Each bank is subdivided into strata. These horizontal lines are strata. To understand the incredible story that this film has to tell, a closer look at the strata in the bank is necessary. They follow a pattern. The larger particles collect together in a line at the bottom, and then the smaller ones gather on top. This pattern is repeated throughout the bank. Sometimes a break or joint can be seen between the top strata in one bank and the bottom strata in the bank on top. These breaks are called stratification joints.
For some time now, there's been a suspicion that these rocks contain a secret, which when discovered will change our ideas on the most important subject of all, How did mankind originate?
One of the first sedimentary rock experts was a German. His name was Johannes Walter. Whilst in Italy, at the end of the last century, he examined the sediments in the Bay of Naples. He discovered, by boring vertically downwards through the sediments in the bay, that the banks that lay on top of each other were in the same sequence as those that were lying next to each other horizontally. The sequence of banks that could be seen lying side by side as he went from the coast out to the sea was the same as the sequence of banks that lay on top of each other in a downwards direction. He realized that the belief that the bank at the bottom was older than the one on top was wrong. Quite obviously, all the banks, the one at the top, the one underneath, and the one at the bottom, were all still forming. They were forming sideways, so that part of the top bank was the same age as part of the bottom bank.
It didn't take Walter very long to work out what caused the banks to form sideways.
The particles of sediment coming into the sea from rivers, floods, and wind sort themselves according to their size. These larger particles, coloured yellow, stay near to the coast. The less heavy ones, coloured blue, are washed out a little farther. Then the tiny sediments, the orange ones, are carried out by the waves and currents even farther. It can be seen that the layers of new sediment are deposited side by side. The particles of sediment in the layers sort themselves out according to their size into the banks of various types of sediment. This could be a bank of pebbles, this a bank of sandstone, and this one clay. So the banks form sideways. That part of the bank nearest the coast is older than the part of the same bank farther away from the coast. So this part of the bank at the bottom is the same age as this part of the bank at the top.
The reaction of the other rock experts was that Johannes Walter's discovery only explained coastal rocks, and that deep sea sediments were always formed by a layer of sediment forming on top of another, and that the layer on top is always younger than the layer underneath. In this cliff face, probably formed from deep sea sediments, the strata in the banks at the bottom are believed to be much older than the strata up there in the top. The reason for this is that geologists believe that strata and layers are the same thing.
In the 1970s and 80s, several holes bored into the bottom of the Pacific Ocean by the Glomar Challenger vessel produced samples of sediment that showed Walter's discovery applied to the deep sea sediments just as well as coastal sediments. This meant that virtually all sedimentary rock formations in the world must have been formed in the same way.
So what does all this mean? Well, take what is considered to be the biggest, the widest, the deepest, the longest canyon in the world, the Grand Canyon in the United States. The sides of the canyon display banks, one on top of the other, from the bottom of the mile-deep canyon to the top. Each bank is said to indicate an age in geological time. Yet, what we know from Johannes Walter's discovery and the Glomar Challenger deep-sea borings indicates that parts of different banks could be the same age. Nevertheless, there were still those who found this difficult to accept. But two recent events have occurred, however, which should remove all further doubts.
In 1980, Mount St. Helens, a volcano in the United States, exploded. It flattened an extensive forest and caused a tidal wave in a large local lake. Within hours, 600 feet of sediment had formed, which dried into rocks complete with strata. As a result of the explosion, huge amounts of mud flowed through the adjacent rock.
From some primitive animal whatsoever. For what we can say, observing the human chromosomes or the human DNA and comparing it with that of other species is data at all.
One of the problems facing geologists today is the fossilized tree. There are a number of examples in Australia and America and elsewhere where a fossilized tree can be seen running vertically through a number of coal seams. Here's an example from the coalfields of Birmingham in Alabama.
That man is original. Man is not derived from any other species. So the statement that man is a recent creature coming from some primitive form cannot be supported by genetic.
United States. Some of these fossilized trees, 12 meters or more in height, can be seen running through a number of banks. This model gives some idea of the situation. Now, the curious thing is that we are told that any one of these banks takes millions of years to form. Now, if this was the case, it would take millions of years to bury the tree. But that's not possible, because the tree would decompose or rot long before it was all buried. So, what is the explanation? Well,